Christopher Nolan. Now, let's imagine being lost at sea. It's become a familiar grumble in recent years that in the age of sat-nav, people no longer know how to read a map. Well, something equivalent has become a concern of the US Navy. Its ships navigate by GPS, as you would expect, but the Navy's asked itself what would happen if a cyberstrike took the GPS technology down. So this year, it's reintroduced basic training in the lost craft of celestial navigation. Shall we find out what that entails? Sailor, author and fellow of the Royal Institute of Navigation, Tom Cunliffe, is here to give us a lesson in the unhackable technology of, well, it's the sextant, isn't it?
There it is.
How hard is it to use a sextant?
Using the thing is not difficult at all. Actually, it's a very old instrument. So that's from 1942.
This looks pretty old. Yeah,
it is.
Weighty old thing.
Yeah, it is. That went round the North Cape in World War II, that one did.
Right. OK, well, look, we provided you with stars at great expense. We've highlighted Orion. How do you use this to take a position then?
The purpose of the instrument is to measure angles with extreme accuracy. This sextant, this ancient sextant, will measure the angle between one of those stars and the horizon. Let's call that silver line there the horizon.
Right, okay.
It will measure it.
Show us how you do it then. What do you do?
Yeah, okay. You grab hold of the sextant. We'll forget about the lanyard.
You won't put that on so you don't drop it in the sea.
That would go on, yes, but we'll not bother with it now.
Right.
We sight looking at the star. The light comes from the star. It hits this mirror.
Okay.
Bounces onto that mirror.
Right.
Comes through the telescope and into my eye.
Okay.
Meanwhile, there's a plain glass half to that mirror. That looks straight at the horizon. And the difference between this angle and that one is what I'm seeing, the star and the horizon.
And every time, at every position on Earth, there's a kind of a unique angle for that star and the horizon. So
there is. It's not a position, actually, Evan.
It's not a position?
No, it's not a position. It's a position line. If I get that angle, which I can measure to 1/10 of a minute of arc, which is 200 yards at the equator, if I measure that accurately and get the time, it will give me a line on a chart.
Wait, it gives you a line?
A line. And I know I'm on that line, but I don't know where I am on the line.
That's completely useless.
No, because if I get another line...
Okay, sorry. Right, that's triangulation. Okay, you're going to do it. Right.
The two cross.
Were especially fascinated with the most mysterious invisible force of all, magnetism. The result of their fascination was the creation of the world's first magnetic compass. This was called a sinon, a section of lodestone, which is naturally magnetic, was carved into the shape of the Big Dipper and placed on a polished board. The circular center of the board represented heaven, and the square represented earth, and the spoon the Big Dipper. This constellation was especially sacred, as 2 stars in the Big Dipper always point to the pole star. The Emperor was the earthly counterpart of the pole star, around which all the other stars rotated. Hundreds of years before the first compass was to be found on a European ship, small factories in China mass-produced a variety of compass designs. The world's first prototype of the dry modern navigational compass was called the magnetic turtle. South was indicated by the direction of the needle, which was attached to a magnet concealed inside the model. Around the year 850 AD, Chinese ships began to carry a water compass to help them navigate during murky weather and storms, when there was no way to use the sun or the stars. This simple mariner's compass would always point south, unlike modern compasses today.
Then Chinese used a little steel needle to replace the spoon. This made the Zhinan zhen easier to carry. "600 years ago, Zheng He, a famous eunuch of the Ming Dynasty, traveled to Southeast Asia and the Indian Ocean 7 times. Zheng even reached the Red Sea with the help of the Zhinan zhen. The invention boosted the development of navigation.
We all know the functions of a compass to give the right direction with respect to north and south pole of the earth by use of magnetism. But due to interference in communication, the smartphone does not use a magnet. As one of its components, the smartphone uses a new technology which does the exact same work as a conventional compass does. The smartphone have a small magnetometer built in, which can measure the Earth's magnetic field. This information is combined with accelerator that acquires information regarding to the phone in space. If ultra-low frequency signals coming from a specific direction like north or south pole, the accelerator can actually calculate the exact orientation and direction of Earth. This can be possible by Hall's effect. In 1879, Edwin Hall idealized the voltage difference across 2 electrical conductors. When the electrical conductors arise, transfers to an electric current in the conductor and an applied magnetic field perpendicular to the current. By using the Hall's theory, it was too easy for scientists to put sensors at different angles. Thus, by the use of multi-sensors at different orientations, one can actually have their own magnetic field which can be compelled with the Earth's magnetic field. By analyzing Earth's magnetic field, the sensors allow a phone to determine its position and the direction very accurately.
The Hall effect is the most common method of measuring magnetic field, and the Hall effect sensors are very popular and have many contemporary applications. For example, they can be found in vehicles as wheel speed sensors, as well as crankshaft or camshaft position sensors. Also, they are often used as switches, MEMS compasses, proximity sensors, and so on.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. RD-180 ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the 12th GPS-2F satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing service for military and civilian users. Zero.